now we'll actually move into how UART works, the serial communication part, the breakdown of the UART protocol, and we're going to briefly touch base on baud rate, start bits, stop bits, and parity.
Sure.
Right. So on to you, Shravan.
So how does UART works, right? So what it consists of? Okay, so in the UART, if you can check, then there is a frame rate. Okay, in UART frame, so there are total 4 sections. Like if you are compare with the other protocols of serial communications, then there is a clock is there already. So it depends upon the clock, how it start, like where it is start. So clock will be generate the pulse so that we can actually know when the data is transmitting and when the data is receiving. Okay, but in the section of UART it is unsynchronized. Because of that we are not having a clock. Because of that we are unable to know that where the data are starting and ending. Because of that we are having one of the section in the UART frame is start bit. In the start bit we will get to know that when the data is transmitting, and also from the stop bit we can get to know that here the data is ending. And then in the middle of that part we have a message bits that the character is of 0 to 7 of bits, total 8 bits data are there. So we can send a message of, and whatever the messages are there, whatever binaries are there, so we can keep into the message bits. And along with that we have a parity bits also. In the parity bits, if you can see, then if you have an errorness or something extra bits of data, then we can adjust in the parity bits, so we can transmit the data along with the start, message bits, parity bits, and stop bits. And also we have most importantly thing, that is the baud rate. If you are having a device and you are connecting the device with the terminal, then if you don't know about the baud rate, then there will be a bigger mistake, because then the data will not be displayed as per your need. Because if you know about the baud rate, how it is functioning, like 9600, 115200, 57600, so it depend upon the baud rate how it is functioning the device. If you can check, then if we are having an access to UART functionality, then there is a dedicated UART a baud rate from the company itself. If you have access to, if you can check it 57600 is for example, then data will be displayed as per the boot kernel, and images and the root shell access, everything will be displayed along with that. But what if the company is a block, and also sometimes what they do is they disable the UART pins. Because of that the baud rate also not work. So it depends upon the how the companies is reacting to the security concern. So this is how the UART works, with consisting of the start bit, end bits, and message bits, and along with that parity bits. And also the baud rate should be known about that. Because of that we can have an human readable data.
Okay, wow, that was a lot of information. I learned quite a bit. Now, let's talk about the applications of UART. What are the common use cases in embedded systems? Examples in consumer electronics and telecommunications, and how would you compare it with other protocols, right? So that'll be SPI, I2C, and other ones, right? So yeah, Shravan, please.
Okay, so for the UART sections, if you consider applications, there are lots of applications. If you can see the home automations, if you have smart home automations and ecosystems, whichever, if you can take an example of Alexa, more secure devices. So in that also what they do is for communication purpose, they just keep most of the test pins like JTAG, UART, SPI, I2C. So because of that the interaction is very much friendly and easier. But it depends upon the company, like Amazon or Chinese products or other companies. So it depends how they are reacting to the security purpose, right? So in as per the Amazon or any of the services, as we have already worked on the devices, so what they do is secure protocol, secure boot process. So they just take all the considerations and they take the accordingly. But mostly companies if you can take an example of a Chinese company, what they do is like they are just making a products for the industry. They are making just for like introduced in the industry, and then after that the product will be like distributed to the home consumers. So in that devices, if you can check, the UART section is easily accessible, and from the device you can check the whole boot process, kernel image, and all the data which are transmitting. If you can have an the Wi-Fi module inbuilt, then there will be a more problem with that, because the SSID, password, all are in the clear text, because they are not in putting the efforts to the encrypting the data. Because of that, this is very severe issues, and these are the applications where the UART can be used in the home automations, and also the devices which are at a higher scale, like in industry and then ICS. So these all the industries are using the UART. And also if you can see in the smartphone, GPS module, modems, these are all the in the routers also, in the all the things are consisting of the UART. If the JTAG is not present, but the UART has to be there, because the most interactions part of that the device. And also if you can have a look into the image of this, so you can check it as this is a tool of TTL to USB. So from these tools we can have an easily accessible of UART communications. As you can check here is 5 pins over here, like 3v3, TX, RX, GND, and then 5 volt again voltage. So in this also, if you can check TX and RX is main pins of the UART. So from that the receiving and transmitting text part, and then the 3v3 is for optional. Because of that, if you have a device power, then we don't need in the 3v3 and 5 volt. And the third one, from after the RX and TX, there is a GND for the common ground, so that after connecting the RX to TX, TX to RX, and GND to GND, we have an a Picocom screen and then Arduino IDE software, so that we can have an interaction with the UART of boot process and everything, whatever the root shell access, whatever going on. And as compared to the other protocols like SPI, I2C, and JTAG, so why UART is common and why it is essential, right? So in SPI, I2C, these are the clock based, and also they are the one half duplex and full duplex. In I2C, if you can check, then the messages are transmitting interconnected circuit. So one at a time we can transmit we can transmit data in one frame. Like if we can read it, then only we can read it. If we can write it, then only we can write it. Or in SPI, there is a based off we have data. If we are selecting slave and masters, if we have a different multiple slaves, then only master will be it will work on the master's way, and the slave will be like peripherals, and then multiple masters will be there, then one slave will be organized with the messages. So it depends upon the clock how it is organizing, because that's why they are the more complex way. And in UART, if you are connecting, then the boot process we can dump the firmware, and then we can analyze the firmware in serially. Okay, so that's why the UART is very commonly and user friendly protocols. And in JTAG also there are multiple pins, because of that that is more complex way. And SWD and other protocol also there, but they are more complex and not user friendly. And UART is more user friendly, and it is easy to use. And also this is consisting of 4 pin, that is VCC, GND, RX, and TX. That's it.
Excellent.